Morning, grade fives. I'm so lonely in my office. I decided that I would show my dogs what it is that or who it is that I'm talking to in my office all alone. I don't think Pirate here really gets it yet, but at least now he knows that I'm not talking to anyone and not ignoring him. All right, good morning, fabulous grade fives out there who are watching the show. Now that I've put my distractions aside and we can get on with the lesson. I hope you had a good night's sleep and that you're relaxed and healthy and ready for another maths lesson. We've been looking at fractions, but before we get back into fractions and looking at subtracting of fractions, I did just want to check in to see how your times table challenge is going. So remember, if you haven't been doing it yet, I'd like you to learn your timetable, time yourself doing your timetable, and then practice and see if you can get quicker at doing your times tables. If you are getting quicker, if you've got a really good time for one of your times tables that you'd like me to try and beat, let me know. I definitely have had some students in the past who've been quicker than me, so maybe you'll manage to do that as well. Let's dive into our fractions for today. A reminder that if you have any questions, email me grade5@worksheetcloud.com. After the lesson, if you'd like to check that you've understood what it is that we've done, you can click on the link above and do the worksheet. Today, fractions 5, our fifth lesson of fractions. We're going to look at subtracting fractions. And also, because subtracting fractions is so similar to adding, and it's very straightforward, we're also going to look at adding fractions when we end up with a whole number as our answer. So to recap, firstly, recapping the important rules when we are adding fractions. The denominators need to be the same before we add the fractions, and we don't add the denominators. Our goals for today: we'll be able to, hopefully by the end of the lesson, subtract fractions without a problem, both with the same denominator and with different denominators. And we'll also be able to add fractions when we get a whole number as the answer. We're going to do a quick review of yesterday's homework, and the reason we're doing that is because it's going to help us with today's work. Okay, looking at the first one, you'll notice that our denominators are the same. So we don't need to change anything before we start. So just make it a bit bigger on my iPad. We can start straight away with our equal sign. Our denominator stays the same. 1 plus 3 is 4. Straightforward, 4 over 11, or 4/11ths. Number 2, I gave you 2 where the denominators were already the same. Don't have to change anything. So the denominator stays the same. 5 plus 1 is 6. There's our answer. In number C, or in letter C, the third one, our denominators are different. And so before we move on to adding them, we have to make the denominators the same. This is where your times tables help. So I hope that you notice that if we times 2 by 2, we can get it to 4. And what we do to the bottom, we do to the top. So our first fraction, and I'm going to do it in black, stays in the same place. Nothing has changed. It's not maths. It's just rewriting or copying. Our second fraction, we have changed. So 1 times 2 is 2. And 2 times 2 is 4. The only reason we're changing it is we're using equivalent fraction. Oh, sorry, that should be a plus. We're using equivalent fractions, and we're doing that so that we can get them to both be over 4. Now that our denominators are the same, we can add them. So denominator is the same. 1 plus 2 is 3. There's our answer. In letter D, 3/8 plus 1/4. You'll notice that if we times this by 2, we can get them to both being 8ths. So first one, unchanged. And it is important that we keep them in the same order With plus, it won't actually change the answer, but we need to get in the habit of keeping them in the same order. Otherwise, we end up with the wrong answers when we do subtraction. So what I mean by the same order is the one that was unchanged was the first fraction, and it should still be the first fraction and in front of the plus sign. And the one that we changed, or we found the equivalent fraction for, is after the plus sign, and it should still be after the plus sign. So 1 times 2 is 2. 4 times 2 is 8. Now our denominators are the same and we can add them. 3 plus 2 is 5. There's our answer. Looking at the following one, this is the last of the ones where we only have to change one of the denominators. You will notice that if we times that by 4, we can get to the same one. I say if you notice that, I notice them quite quickly because my times tables are quite good. I hope that you would also notice that 2 is in the 8 is in the 2 times table, and we can get a 2 to be an 8 by timesing it. So this time, the one that we changed or found an equivalent fraction for is the first fraction in front of the plus. 1 times 4 is 4, 2 times 4 is 8, and the one that we did not change was after the plus sign, and that stays as 1 over 8. Denominator is unchanged, 4 plus 1 is 5. So the same answer for those two questions, even though the numbers in the question were different, the fractions in the question doesn't matter, we still get the same answer. Okay, looking at F, and this time we will notice, or you will notice, or I hope you notice, that we've got two numbers that we need to change both. So we need to find something that both 2 and 3 fit into so that we can add them. So on the side, I'm just going to quickly jot down my 2 and 3 times tables until I find something that's in both. So 2, 4, 6, 8, 10, and 3, 6, 9. I already got it. You can see that 6 is in both. So I'm going to change both of these denominators to equivalent fractions so that they are over 6. So if I times this by 3, I must do the same to the top. Oh, give myself a little bit more space there. So 1 times 3 is 3. 2 times 3 is 6. And with the second fraction, if I times that by 2, I must do the same to the top. 1 times 2 is 2. 3 times 2 is 6. So I found equivalent fractions for both of them that then give me the same denominator at the bottom. And now that I have the same denominator at the bottom, I can add them. Remembering also to keep the order of the way you're writing them down is the same. Denominator stays as 6. 3 plus 2 is 5. There we go. Next question uses the same. We've got to first of all find something that both 3 and 4 go into. So I'm going to jot down my 3 and 4 times table. I have my 3 there, but I'm going to just do it again. So 3, 6, 9, 12, 15, and 4, 8, 12. And there we go. I've already found it. So I need to change these to both be fractions with twelfths at the bottom. So if I times that by 3, I can get a 12th. And I get 2 times 3 is 6, 4 times 3 is 12. And for my second fraction, I can do 1 times, let me start at the bottom, times 4 and times 4, so I get 4 over 12. I now have the same denominator, so I can add them. 6 plus 4 is 10. There we go. Here's our answer. We have one more that we did for homework. This one we've also got to find something that they both go into. I'm going to quickly erase my times tables on the right so that I've got space to do my new 2 times tables. So the 5 times table, 5, 10, 15, 20, and 3, 6, 9, 12, 15. Oh, just enough space. There it is, 15 times by 3. If you want to know how I can, I'm checking. I need to make it 15. So I go 5, 10, 15. So I times it by 3. And what I do to the bottom, I do to the top. So this fraction becomes 3 times 3 is 9 over 15. This one, I've got to get the denominator to 15. So 3, 6, 9, 12, 15. It's times by 5. So 1 times 5 is 5. 3 times 5 is 15. Remembering to keep the order the same. Now that I've got them there, easy to add. And 14 on top. All right, so that was the homework. Because there's such a lot of similarity between plus and minus, I did think it was worthwhile to spend the time going through there and just making sure. With all my arrows across there showing that the order stays the same, that is very important, particularly in what we're coming to now. If you don't do that, you're going to end up with the incorrect answers. So the rules for subtracting fractions are pretty much exactly the same. First of all, we have to make sure our denominators are the same before we subtract. And secondly, we don't subtract the denominators. So with addition, we don't add them, and with subtraction, we don't subtract them. Right, so here's the challenge. I'm not going to do any worked examples before I start asking you to try these on your own. And the reason for that is because there is such a big similarity. So I'll give you a few, for the first couple, I'll give you about 30 seconds to do them before I work through them. If you struggle with them, just watch me as I work through them, and we'll do, I think, 6 in total. So let me check what I decided was our first one. Number 1, we're going to start with 6 over 11 minus 1 over 11. Okay, take a moment to get started with that. I'll give you about 30 seconds. In the meantime, I'm going to put down the next question for anyone who's already got this one right. Okay, I reckon that's enough time that you've had a chance to look at number 1. So with the first one, we were first of all checking our denominators are the same, which they are, which means we can go straight to the answer. Denominator stays the same, we don't subtract it, and then 6 minus 1 is 5. Now, I do want to point out to you that the most common mistake I see in grade 5s is that they forget to check the sign, and they end up doing 6 plus 1 is 7 and getting 7 over 11, which is incorrect because you've done the wrong thing. So please be very careful to pay attention to the sign. In fact, this is so important that in the homework today, I've mixed up plus and minus. So right from the start, you get used to the fact that you're checking whether you're doing plus or minus. In the second one, we need to check. Oh, no, let me give you a couple of moments to get started with that one. For those of you that have already finished that one, an interesting thing that's not really related to maths, but maybe it is in a little way, is that a moment is an actual measurement of time. And it's not a really short measurement of time. It is 90 seconds. And maybe at the end of the lesson, I'll explain why that is. Okay, having a look again at number 2, you will notice our denominators are not the same. So before we subtract, we need to make our denominators the same. I notice that I can do something to a 3 that will make it into a 9 because 9 is in the 3 times table. So 369 times it by 3. What I do to the bottom, I do to the top. First one, I'm just going to rewrite. That's 5 over 9. I haven't changed it. Second one, I'm changing. 1 times 3 is 3. 3 times 3 is 9. Just writing it as equivalent fraction. I say changing, but it's just a different way of writing the same thing. That's why we have equivalent fractions. Now that my denominators are the same, I can do my subtraction. 5 minus 3 is 2. Here we go. I hope you managed with that one. Let's try the next one. In this one, you'll have to change both of those denominators. Okay, that should have given you enough time to get started. You will notice that we have to change both because they're not the same. On the right-hand side of the screen, I'm going to quickly jot down in fact, let me do it at the bottom. I'm going to jot down the 4 and 3 times table to see what I need to make it in. So 4, 8, 12, 16, 20, 3, 6, 9, 12. There we go. So we need to make both of those denominators 12. So if I look at the 4 to make it into a 12, I go 4, 8, 12. I times it by 3. And what you do to the bottom, you do to the top. So the first equivalent fraction is going to be 9 over 12. And the second one, I've got to make that to a 12. So 3, 6, 9, 12 times 4. And what you do to the bottom, you do to the top. 1 times 4 is 4. 3 times 4 is 12. I now have the same denominator. 9 minus 4 is 5. There's my answer. Have a go with number 4. Right, if you're not finished with it, let's work through it together. So having a look at 2 and 3, we need to make them into the same denominator. So I'm going to jot down my 3 and 2 times table. 3, 6, 9, 12, 15, 2, 4, 6. I already got there. I've got to make them into 6s. So to make it 3 into 6, 3, 6. Times it by 2. Same to the top. 2 times 2, 2 times 2 is 4. 3 times 2 is 6. Looking at the 2 to make it into 6, 2, 4, 6 times by 3. Same to the top. 1 times 3 is 3. 2 times 3 is 6. I now have these same denominators, so I can subtract 4 minus 3 is 1. Here we go. Let's try number 5, the second last one we're going to do. Looking at number 5, 5 and 3, we need to make them the same. I need to see what they both go into. So let me jot the times tables down. 5, 10, 15, 20, 25, 3, 6, 9, 12, 15, 18. Oh, there we go. I got 15. So we need to make both of those denominators 15. To make a 5 into 15, I go 5, 10, 15 times 3. Same to the top. 4 times 3, wrong color. 4 times 3 is 12. 5 times 3 is 15. Let's have a look at my other one. To make a 3 into a 15, 3, 6, 9, 12, 15 times 5. same to the top. 2 times 5 is 10. 3 times 5 is 15. Now that my denominators are the same, I can add them. Or not add them, I can do my subtraction. So denominator stays the same. 12 minus 10 is 2. Here we go. And the last one. Okay, having a look at the last one. Better just make a little bit more space at the bottom so you can see. You might notice that you could just put 7 into 14. If you didn't, we can do the times table. 7, 14, 21, 28, and 14. And you'll notice that the 14 is already there, and we just need to change the other one. So if I times this by 2 and this by 2, I get the new number, which is 14 over 14 minus 1 over 14 equals 13 over 14. I deliberately chose this first one, which looks a little bit different, because it leads on to the next thing that we're going to do this lesson, which we have just enough time for. So 7 over 7. And remember we discussed how a division sign is the same as division. What is 7 divided by 7? That's right. If you've got 7 things and 7 people, you share them out, they each get 1. So this fraction here is actually equal to 1. So another way that we could have written this question is 1 minus 1 over 14. That would have been a little bit more complicated to look at. But we could just then rewrite our 1 as 14 over 14, because 14 divided by 14 is 1. Anything divided by itself is 1. And the reason I chose 14 as my bottom number is because I was looking at 14th on the other side, and so it made sense. Anyway, we're actually going to work not with minus, that's, I think, grade 6 work. We're going to work with adding until we get to a whole number. So adding fractions that take us to a whole number. Let's just do that with some practical examples. So let's have a look at this one here. 2 over 3 plus 2 over 6. So this shouldn't really take you all that long. I'm going to shoot through this one quickly before you try one on your own. So if I times this by 2 and this by 2, I get to 4 over 6 plus 2 over 6, which equals 6 over 6. And again, all I'm asking you to do at this stage is to notice that 6 divided by 6 is 1, and to add that extra step in where we write that it's equal to 1. 1 for you to try on your own, in fact 2 for you to try on your own. 1 over 4 plus 6 over 8. Notice that we're using plus again. We jumped quickly from minus to plus. Work that one out, and there's one more after that. 1 over 3 plus 4 over 6. Looking at number 2, we needed to make our denominators the same. if I times that by 2, I can get to an 8. So I'm going to do the same to the top. 1 times 2 is 2. 2 times 4 is 4 times 2 is 8. The other one stays the same, unchanged, 6 over 8. I get 8 over 8. And the final step is to notice that 8 divided by 8 is 1. Have a quick stab. I'm just going to give you 20 seconds to try the last one. Right, I think that's enough time. I noticed that if I times this by 2, I can get it to be a 6. 1 times 2 is 2. 3 times 2 is 6. Second fraction stays unchanged. 6 over 6, which is equal to 1. Right. Good. We have just enough time for what I wanted to finish off with. This is probably the hardest part of maths, is when we take maths and we put it into words, and then we have to take the maths out of the words. So word problems is what I'm talking about. So whether you're doing time word problems or operations word problems or fractions word problems, it's the hardest part because we've disguised our maths in language and we need to take it out. But at the same time, actually, this is probably where maths happens the most in real life, because normally you will have a problem you have to work out and you have to first take the maths out of the language. So let's start off by that. So Carla and Dion are on holiday in wilderness. Their dad hires a kayak for an hour for them to use. Dion uses it for 2/5 of the time. Carla uses it for 3/10 of the time. How much time left till they have to take it back? All right, so let's find out how much they used it to start off with. So taking out the maths, let's see, an hour, so that would be 1 hour. I'm going to jot that down, 1 hour. Dion uses it for 2/5 of the time. And Carla uses it for 3/10 of the time. Let's jump across to our whiteboard where I've jotted down the important information. So first of all, it was hired for 1 hour. Then we know that Dion uses it for 2/5 and Carla used it for 3/10. So let's find out how much they used it for altogether. So I guess we need to add that. So 2/5 plus 3/10. Well, we first need to make our denominators the same. Times 2 equals 4 over 10 plus 3 over 10. So together they used it for 7/10 of the hour. So that's how much they have used it for. If we look back at the question was how much time left till they have to take it back. So this is a little bit more complex. Well, we started off with an hour, 1 hour. So 1 hour. Because we're looking at tenths, let's write our hour as 10/10. That is 1, so 1 hour is equal to 10/10. So now, if we want to find out how much time is left, we're going to take our 1 hour, or 10/10. We're going to subtract how much time we used it for, and then we can find out how much time is left. So it's 3/10 of an hour. Now, the question didn't ask you to turn it into minutes. It just asked you to find out how much time left till they needed to take. So you could leave your answer as 3/10. But it's a word problem, so we need to write a word answer. There were 3/10 of an hour left till they needed to take it back. All right, good. So we have reached the end of today's lesson. Remember to do your times table challenge. Remember that if you have any questions for me, and I love to have questions for me, just email me at grade5@worksheetcloud.com. Perhaps your teacher at school is covering something different at the moment and you'd like some help. Let me know. We'll see if we can include that in some coming lessons. Reminder that you can click on the link just above the video to get today's work, and that's really just to check whether you have managed with today, and you'll be able to watch this video as many times as you like. So from Pirate and myself and my other dog, who I might introduce you to tomorrow, we'll see. Have a fantastic afternoon, and thank you for joining us. Goodbye.